myself here. Let me turn over to page 57, and here we go. Numbers 1, 3, and 5. The directions say to plot the numbers on a number line, then state which one is greater. Now, if you want to use a number line, fine. Please don't be embarrassed of that if you need to. If you don't need to, that's fine also, okay? 2/3. If you struggle with fractions, there's a couple ways to do this, okay? First of all, you can write both fractions with the same denominator, okay? So 2/3 becomes 8/12. 3/4 becomes 9/12. I just found a common denominator for 3 and 4, which is 12. Obviously, 8/12 is smaller than 9/12, okay? That's one way to do it. Probably the faster way is to take your calculator, type in 2 divided by 3, and you get 0.6. 3 divided by 4, 0.75. So obviously, let's put a 0 here. So they have the same amount of decimal places, or a 6, I guess. 0.66 is less than 0.75, okay? So the number that's greater is 0.75. But I would like your answer to be, I'd like you to use the original number. So 0.75 is the same thing as 3/4. So the answer is 3/4. Okay, moving on to number 3. Which number is bigger? Now, sometimes negatives can be confusing. So here's 0, -1, -2, -3, -4. Which number is further to the right? Remember, on a number line, as you move to the right, the numbers always get larger. Always, okay? And as you move to the left, the numbers always become smaller, okay? So, which number is further to the right? -3. So -3 is the bigger number between -3 and -4. Number 5, if you take your calculator and type in square root of 3, you're going to get 0.173. So if I round one decimal place right here, I'm going to get 1.7. I think I said 0.17, 1.7, okay? If that's the case, then these two numbers are identical. However, if you round this to 2 decimal places, you get 1.73. Alright, now, remember how to compare decimals. Always make sure the two numbers you're comparing have the same amount of decimal places. This number has how many decimal places? 1, 2. This number has how many decimal places? 1. So add a 0 here, and that will help you. 1.73 is bigger than 1.70. So this is your larger number. Of course, I want you to write the actual number, which is square root of 3. So there's your answer. Number 7. Numbers 7 and 11, we're going to write the numbers in increasing order. Now, you cannot increase unless you start with the smallest number, okay? If you start with the largest number, how can you increase? You can't go anywhere. So if we're going to write these in increasing order, we must start with the smallest number and work to our largest. So I would first of all get all of these in decimal or whole number form. It looks like we've done that. So for me, I'm going to put them on a number line. That's just how I like to do it. So I'm going to say 0. I'm going to put -2 right here. And actually, I shouldn't put a 0 there because then we think that's one of the numbers. So there's 0. Here's -2. Here's -0.5, which is -1/2. -0.5. 0 is one of my numbers. 0.5 is one of my numbers. -1.5, that's about right here. -1.5, and then the number 1. So now that I've put them in order on a number line, now I just start left and work my way to the right. So -2, comma, -1.5, comma, then -0.5, comma, then 0, comma, then 0.5, comma, and then 1. So I've started from the smallest and worked my way to the greatest. Number 11. Now here it's a little trickier, so let me help you, okay? You have a negative square root of 2. So I'm going to type that in my calculator. I'm going to get -1.41. Now, I see we have some other -1.41s, so I'm going to round this to 3 decimal places. -1.414, okay? For this right here. Now, positive 1.414. Okay? Now, we've got a bunch of decimals, students. The easiest way to compare decimals, guys, is to make sure they all have the same amount of decimal places. So these two numbers here that I'm circling have 3 decimal places. This number here has 2, so I'm going to add a 0. Now it has 3. Add a 0. Now it has 3. Add a 0. Now it has 3. Add a 0. Okay, that's going to help. Now, let's look at my negative numbers first. It's going to be really hard to put these on a number line because they're so close together, okay? So I'm going to spread them out a little bit. Negative 1.414. I'm going to put that about right here. Negative 1.414, which of course is negative square root of 2. Now positive 1.41, so we'll put that about right here. 1.41. Now look at this. Negative 1.420. Well, guys, think about it. If I'm at negative 1.414, I've got to go more to the left to get to negative 1.420. 414. Next would be 415, 416, 417, 418, 419, 420. So that's how I know which way to go. So over here I'm going to put negative 1.42. If you want to put the 0, you can. You don't need to. Alright, square root of 2, that's positive 1.414. Now, if I put a 0 with this one, that's 1.410. This is 1.414. Obviously, 414 is going to go to the right of 410. This is 1.410, then 0.411, 0.412, 0.413, 0.414. So over here to the right, I'm going to put 1.414. And then lastly, right here, I have 1.420. That would go right here. 1.420. How did I know that? Because I'm at 4.14 or 414, then 415, 416, 417, 418, 419, 420. Okay, so there we go. Now, to write these going left to right is pretty simple. I think I'm missing one somewhere. 1, 2, 3, 4, 5, 6. Which one am I missing? Let's see. This one here. And then this one. And then this one. And then this one. Oh, I skipped this one right here. Negative 0.400, negative 1.410. That would go right here. Let me show you why. 1.410. Well, guys, 0.410, 0.411, 0.412, 0.413, 0.414. Okay, so it goes right here. And now I have my 6 numbers. So first would be negative 1.42, comma. The next would be this number, but be sure and use this negative square root of 2. And by the way, also above this number right here, I should put square root of 2, so I don't forget that. Then moving to the next number, negative 1.41. You can put a 0 if you want to. You don't have to. Then comma, this number's next, 1.41. Then comma, this number's next, square root of 2. Then this number's next, 1.420. That's how you would do that, and those can be pretty challenging, okay? So be really careful with your decimals. Alright. Numbers 15, 16, 15 through 19, the odds, we're going to substitute and evaluate. So b equals negative 2. I have a b right here, so I'm going to put negative 2, then parentheses for b, and then a squared. Where the parentheses is, I will substitute negative 2. Now, this 2 right here is going to the negative 2, okay? So if you were to multiply these two numbers first, negative 2 times negative 2, and put a positive 4, and then bring down your exponent, there's no way that's correct. The 2 is going to a negative 2. The 2 is not going to a 4. Do your exponents first. So bring down your negative 2. Then put a dot because they're multiplying. And now square your negative 2. So negative 2 times negative 2 is a positive 4. Negative 2 times positive 4, negative 8. Alright. Moving on to number 17. Alright, here we go. Y equals 4. So I have a 5 square root. So 5 times 2 plus 2, or positive 2. 5 times 2 is 10, plus 2 is 12. The answer is 12. Moving on to number 19. Alright, up top here I have a and a b, so 3 parentheses, parentheses, and then a power of 2 from right here, and then plus 1. Okay, now let's write the denominator, 3ab, so 3 parentheses, parentheses, don't forget to put a little power of 2 right here for this power right here, and then negative 1, okay? Now, everywhere there's an a, I'm going to substitute 2, so we put a 2 here and a 2 here. Everywhere there's a b, I'm going to substitute negative 2, so a negative 2 here and a negative 2 here, okay? Now, let's totally forget the denominator for right now, okay? Let's just forget the denominators even there. We're going to worry about that later, okay? For right now, let's just worry about the top of the fraction. That's all I care about, okay? And that's how you want to solve these. Take it one part at a time, okay? The first thing you do is your powers right here, okay? So I have 3 times 2 times, okay, negative 2 squared is 4, and then positive 1. Now I have 3 times 2 times 4, that's 24, plus 1 is 25. So there, now I know the top part of my fraction, 25. Now, let's focus all of our attention to the bottom of the numerator, the denominator of the fraction, and here it is. Do your exponents first. This 2 right here goes to this 2 right here. So this is what we're going to do first right here, okay? So I'm going to bring down my 3, put a times, 2 squared is 4, and then times a negative 2 minus 1. So 3 times 4 is 12. 12 times negative 2 is negative 24. Bring down your negative 1. Negative 24, negative 1, negative 25. So a positive over a negative is negative. 25 over 25 is 1. Negative 1. Okay, moving on to numbers 21 and 23. The directions say to simply evaluate. So here we go. Order of operations. We do all multiplication and division as we see them, and I see some right here. Bring down your negative 3. A negative 6 divided by a positive 2. Negative 6 divided by a positive 2 is negative 3. Then bring down your negative 12. So all these negatives mean you owe me 3, you owe me 3, you owe me 12. That's negative 18. Negative 18. Moving on to number 23. Do all multiplication and division first. So I'm going to bring down my 12. I've got multiplication right here. A negative 3 times a positive 2. Negative 3 times positive 2. Negative 6. Then bring down your positive 5, okay? Well, you have positive $12 plus 5 more. So you have positive $17. But you owe me $6. So you pay off your $6 debt and you're left with 11. 11. Alright, moving on to number 25. Find the area of the blue region. Well, this is actually pretty simple. I mean, I've got a triangle right here. Find the area of that triangle. So, I'm going to flip it so it looks like this. Here's my right angle right here. My base is 4. My height is 4. This triangle right here is this blue triangle right here, okay? So, how do you find the area of a triangle? 1/2 times base times height. So 1/2 times the base, which is 4, times the height, which is 4. This would give you 8. So the area of the blue region up here is 8. Now let's find the area of the bottom blue triangle and then add these two triangles' areas together. Now, think about it. I have a rectangle here, and I know that because I've got a right angle here, a right angle here, and a right angle here. And we learned sorry for yawning, in geometry that a quadrilateral's 4 angles are going to add up to 360. So this is 90, 90, 90. This has to be 90 also, so we have a rectangle. Now, if this is 4 right here, then we know this has to be 4 down here. So let's find the area of this triangle. base is going to be 4. My height is 3. So the area of a triangle is 1/2 times base times height, which would give you 6. So the area of this triangle is 6. Add the two together, 8 plus 6, and you get 14 square centimeters. 14 square centimeters. All right, numbers 29, 31, 33, 35, and 36. The directions all say to solve the equation. Solve the equation. So here we go. You look at this. Do you see any absolute value symbols anywhere like this? No. So we have a simple linear equation. Simplify the left side. Already done. Simplify the right side. Already done. So next, bring your positive 3 over, make it a negative 3. You're left with negative 5x equals positive 18, negative 3 is 15. Divide both sides by negative 5. And you're left with a positive divided by a negative is negative. 15 divided by 5 is 3. So the answer should be negative 3. Alright, moving on to 31. Okay, same thing. Do you see absolute value symbols anywhere? No, of course not. So we have a regular linear equation. Always simplify the left side and the right side first. There's no simplifying over here that you can do. They're both unlike terms. However, here I can take the 3 and multiply it through. 3 times x, you can multiply unlike terms. That's fine. 3 times x is 3x. 3 times negative 6 is negative 18 equals 6x plus 3. Okay? Now, next, eliminate fractions. I don't see any fractions, so the next step, because your variable's on one side and your constant term's on the other, I'm going to bring my negative 6x up, my 6x over and make it a negative 6x. I'm going to bring my negative 18 over and make it a positive 18. Negative 6, positive 3, that's a negative 3x. Positive 3, positive 18, positive 21, divide by negative 3, divide by negative 3, those cancel. X equals negative 7. Positive divided by negative is negative. 21 divided by 3 is 7. Negative 7. Okay, moving on to number 33 now. Don't forget on the test, I'm going to give you problems like this. 2 absolute value 2x plus 5 minus 6 equals 12. And you're going to have to isolate the absolute value. First, you'd bring the 6 over and make it positive. You get 18. Then divide both sides by 2. And you'd be left with 2x plus 5 equals 9. Okay? And then go from there and solve it. So make sure you know how to isolate an absolute value. But anyways, on this problem here, you see the absolute value symbols. So you know right away that you have an absolute value equation. So the first thing you need to realize is hey, I've got to use my steps for absolute value equations. So step 1, isolate the absolute value. We've already done that. So step 2, write the equation 2 different ways. X equals 3, just like it is, and then change the sign of 3. X equals negative 3. Well, look, there's nothing else to do. You're done. Finished. That was easy. Your two answers are 3 and negative 3. Number 35. Okay, same thing. Notice we have an absolute value equation. So because we have the absolute values, we must first isolate the absolute values. Now that's done for us. So moving on to the next step. The next step is to write this as 2 equations. So you write it just like it is. Don't change anything except you drop the absolute value symbols. Then you write the equation again, and you don't change anything except this number here becomes a negative number. And now we're ready to solve. Okay, bring this negative 3 over and make it a positive 3. So we have 2x equals 8. Now divide both sides by 2, and you're left with x equals 4. Over here, bring the negative 3 over, make it a positive 3, and you're left with 2x equals negative 5, positive 3, negative 2. Divide both sides by 2. These cancel. X equals negative 1. A negative divided by a positive is negative, and 2 divided by 2 is 1. So your two answers would be negative 1 and 4. Moving on to number 36. Okay, now, step 1, we notice we have an absolute value value equation. So step 1, isolate the absolute value. So we're going to divide both sides by a negative 2. And that totally isolates the absolute value. It's now all by itself. Negative over negative is positive. 8 divided by 2 is 4. Now that the absolute value is totally isolated, write the problem, the equation, two different ways. Write it just like it is without the absolute value symbols. Then write this equation here the exact same way, except change the sign of this number here. And now let's solve each equation. Here we have a negative 1, bring it over, becomes a positive 1. So that's 3x equals 5. Divide both sides by 3. X equals 1 2/3, or 5/3, or 1.6 repeating. Okay. Now over here, bring the negative 1 over, make it a positive 1. So I'm left with 3x equals negative 4 plus 1, negative 3. Divide this by 3, divide this by 3, and x equals negative 1, because a negative over a positive is negative, and 3 divided by 3 is 1. So the answers should be 5/3 and negative 1. There we go. Okay. Alright, moving on. Numbers 37. Let me lean over here and turn the page. Numbers 37 through 43, the directions say to solve and graph the inequality. Now, I did say you do not have to graph it if you don't want to, but let's solve these. Now, when you look at this inequality, you notice a couple things. Please listen to me carefully. First of all, you should notice there's no absolute values. Number 2, you should notice you only have one inequality symbol. For example, look at number 40. You have 2 inequality symbols. Look at number 39. You have 2 inequality symbols. Okay? So I'm trying to show you there's different inequalities that are going to be on your test. Now this type here does not have an absolute value. It only has one inequality symbol right here. So it's a good old-fashioned, easy, linear inequality. So we simply solve for x. Bring the 3 over and make it a positive 3. So the inequality would read 2x is less than 8. Now, divide both sides by 2. Your 2's cancel. X is less than 4. There you go. X is less than 4. I'm going to lean over and fix the screen here on my computer, so hold on 1 second. Give me just 1 second so I can see it a little better. Okay, moving on now. So there's your answer. X is greater, or x is less than 4. Moving on to 38. Okay, now once again you notice there's no absolute values. So nothing tricky about the problem there. And there's only one inequality symbol. So we have a good old-fashioned inequality. So step 1, simplify both sides. You cannot simplify this side, unlike terms. You cannot simplify this side, unlike terms. Step 2, eliminate fractions. There are no fractions. Step 3, let's move your terms around, okay? So a positive 2x becomes a negative 2x. A positive 4 becomes a negative 4. Negative 3, negative 2, negative 5x. Bring down your inequality symbol. Positive 19, negative 4 is a positive 15. Now, divide by negative 5, divide by negative 5. These cancel. Bring down your x. You divide it by what type of number? A negative number. So turn your arrow. And then a positive 15 divided by negative 5 is a negative. 15 divided by 5 is 3. So your answer is all numbers less than or equal to 3, or x is less than or equal to negative 3. Alright, number 39. Now, notice 39 does not have absolute values. However, it does have 2 inequality symbols. That means we have a compound inequality. Either it's a conjunction or a disjunction. Well, this is a conjunction, and so what we have to do is get x all by itself in the middle. So there are 2 numbers we want to get rid of, a 2 and a 1. Always save the coefficient for last. So let's get rid of the 1 first. It's a positive 1. So we're going to bring the 1 out here and make it negative. Bring the 1 out here and make it negative. You must move it both directions. Negative 3, negative 1, that's negative 4. Inside in the middle, I'm still left with 2x. The 1 is gone. Positive 5, negative 1 is 4. Now I want to get rid of the 2, so we're going to divide everything by 2. By the way, if this had been a negative 2, and you were dividing by a negative 2, you would have to turn x is greater than or equal to negative 2 and less than 2. X is greater than or equal to negative 2 and x is less than negative 2. And there's the answer. Alright, number 40. Now, you notice that you do not have absolute value, so that's good. But you do have two inequality symbols in the problem. 1, 2. That means you have a compound inequality. Now, this is either a conjunction or a disjunction. Well, we just saw what a conjunction looks like, okay? This here would be a disjunction. So we simply solve both inequalities and then bring down the word or between our two answers. So, here we go. Bring the 1 over and make it a negative 1, and I'm left with 3x is less than negative 3. Now divide both sides by 3. X is less than negative divided by a positive is negative. 3 divided by 3 is 1. Now don't get confused and turn the arrow because you see a negative 3 right here. What did you divide by? You divided by a positive 3, not a negative 3. So do not turn the arrow. Now over here, bring the positive 1 over and make it a negative 1, and we're left with 3x is greater than 6. Now divide both sides by 3. These cancel. X is greater than 6 divided by 3 is 2. Bring down the word or, and that is your complete answer. X is less than negative 1 or it's greater than 2. So the answer to this inequality is all numbers less than negative 1 or all numbers greater than 2. Alright, moving on to numbers 41 and 42. Now, notice both of those have absolute values in them. So they're called absolute value inequalities, okay? So they're, you've got to work on these. So here we go. First of all, you always isolate the absolute value. Now, I know it's already isolated, but on your test, you're going to have to be able to isolate these on your own. So if you don't know how to do that, look up the lesson number that these were in. I believe it was lesson 1.7. And look at your notes or watch the video again where I show you how to isolate these absolute values, okay? But in this case, the absolute values are already isolated. So next, we notice our symbol is pointing to the left. Now, never look at what direction. Let me say that again. Never look at what direction your inequality arrow is pointing until you have first isolated the absolute value. If you don't isolate the absolute value first, you will miss the problem. Now, the absolute value is isolated, so now we're going to look at the arrow that's pointing to the left, kind of like a C, which means we have a conjunction. So you bring down the inside of the absolute value and put it right in the middle. Then you bring down your arrows and point them to the left. Bring down your 9, put it here, and then put a negative 9 over here, and then solve. It's that easy. So we want to get x all by itself. We're going to bring our negative 5 out and make it a positive 5 and a positive 5. So negative 9 positive 5 is negative 4. Then bring down your arrow, then bring down your 2x, then bring down your inequality symbol, positive 9, positive 5, positive 14. Now to get x by itself, we're going to simply divide everything by 2. Negative divided by a positive is negative. Here your 2's cancel, leaving you with x. And then 14 divided by 2 is 7. So there's your answer. X is greater than negative 2 and less than 7. So on a graph it would look something like this. The answer to this absolute value inequality are all numbers falling between negative 2 and positive 7, exclusive, because you do not include the negative 2 or the 7. They're open points. So all the numbers in between here. Okay, number 42. Now number 42 is also an absolute value inequality. So the first thing you do is you isolate the absolute value. Now, that's already done for you. So we move on. We then decide whether or not we're going to write a conjunction or a disjunction. Got it? Conjunction or disjunction. So, you look at the arrow. It's not like the other one that kind of formed the letter C. This one's pointing to the right, okay? Like this. So that means we're going to write a disjunction. So what you do is you write the inequality just like it is, identically, just without the absolute value lines. Drop these lines off, okay? Then we put the word or, and we write this inequality exactly case, it's a 2. So I'll put a negative 2. And now we're all set. Bring the positive 4 over and make it a negative 4. I'm left with 3x is greater than or equal to negative 2. Positive 2, negative 4, negative 2. Now divide both sides by 3. These cancel. X is greater than or equal to a negative over a positive is negative. 2 divided by 3 is 2/3. Now, take the positive 4, bring it over, make it a negative 4, and we're left with 3x is less than or equal to negative 2, negative 4, negative 6. Divide by 3, divide by 3. These cancel. X is less than or equal to a negative divided by a positive is negative. 6 divided by 3 is 2. Put your or right here, bring that down, and you are finished. X is greater than or equal to negative 3 like we have here, or X is less than or equal to negative 3. Oh my goodness, look at that. My fault, guys. Negative 2. Negative 2, sorry about that. Alright, negative 2. Alright, okay, moving on to some word problems now. Numbers 43 and 44 both go to this information right here, okay? So here we go. In 1991, Boeing helicopters and Sikorsky aircraft were awarded a $30 billion contract to build the United States Army's new scouting helicopter. Each chopper will be equipped with night vision and will be able to fly 1,250 nautical miles before refueling. That's a lot. And they're going to make about 1,300 of these. Okay, now here's the question. A nautical mile is 6,080 feet. So how many miles will the new scouting helicopter be able to fly before refueling? Guys, pretty decent stuff here, pretty easy. We know already that the helicopter can fly 1,250 nautical miles. Right here it is. Okay. Now, a nautical mile is about 6,000 feet. So every nautical mile I have is 6,080 feet. So I'm going to convert this over to feet. Why would I do that? Because I can then convert feet over to miles. And that's the question, isn't it? How many miles will the new scouting helicopter be able to fly before refueling? So I have 1,250. Every one of those is worth 6,000 feet. So 1,250 times 6,080. Now I would try to do that in my head and impress you, but obviously I can't. So 1,250 times 6080 is giving me 7,600,000. Okay, so 7,600,000 feet. How do I know it's feet? Because look, guys, one nautical mile is 6,000 feet. I've got 1,250 nautical miles, so multiply by 6,080, and that's how many feet are in a nautical mile. Now, let's convert that over to miles. How do I do that? Well, I'm glad you asked. 1 mile equals 5,280 feet. Okay, so all I have to do is I realize every time I have 5,280 feet, I have 1 mile. Well, I've got this many feet, so let's see how many times 5,280 will go into 7,600,000, okay? And then that will give me how many miles that I have. We're basically converting feet over to miles. So with my calculator, 7,600,000 divided by 5,280 gives me this answer right here, 1439.39, repeating. So I'm just going to say about 1,439 miles is how far this chopper can fly before it has to get refueled. Okay? Alright, moving on to number 44. Now, approximate the average cost for each scouting helicopter. Not too hard to do, guys. Really, I mean, we know how much money they were given. They were given $30 billion. And they're making how many? 1,300. So all that you have to do is take 30 billion and divide that by 1,300 to see how many helicopters much each helicopter cost, because the total cost is 30 billion and we're making 1,300 helicopters. So I'm just going to use my calculator real quick. And I'm getting about, let's see, I wonder if that's right. Let me look at the answer here. Yeah, that's right. Okay. I'm getting this right here for an answer. 23,076,923.08. And they put for their answer about 23 million. Just approximate the average. So about 23 million is how much one helicopter cost. That's a lot, okay? It better be able to do some great things. Okay, moving on to numbers. 45 and 46. 45's pretty easy. 46 is pretty tough, so really pay attention here, okay? Here we go. Okay, let's take a look now at 40, or not 45, but the information given for the problem up here. From 1970 to 1990, the average price, P in dollars, of a pound of lettuce can be modeled by this. So if you'll allow me, let's write that model off to the side. Let's talk about it for a second, okay? Now listen to me and let me explain to you what this model means. T equals 0 represents 1970. So this model does one of two things. You can give me a year between 1970 and 1990. And hold on one second, my microphone's giving me some problems here. Hold on. Okay, there we go. Now, listen, you can give me a year between 1970 and 1990, and I can put it in for T right here, and it will tell me how much a pound of lettuce cost during that year, the average price. So, you give me a time, a year, I tell you the price, or you can tell me a certain price, an average price that existed. I'll put the price in, and then I'll put the price in, and I will get out what year the price was, that certain price. So this model does one of two things. It can give you out a price when you put in a year, or it will give you out a year when you put in a price. Okay, all right. Now, the total amount, L, in billions of pounds of lettuce consumed is modeled by this. So this model here is a little different. This model here is, let me write this down for you off to the side so we can talk about it. This model does two things. You can put in a certain year and it will tell you the total amount of pounds of lettuce consumed, or you can put in how many pounds of lettuce were consumed in billions and it will give you out what year it was. So that's what this model does for you, okay? Now, with that in mind, let's see what 45 asks us to do. According to these models, during which year will the average price of lettuce be? 0.765. Now guys, which one of these two models is talking about the average price? Let's go up here and look. Here it is. The average price, P, can be modeled by this model right here. So I want to use this model here. So they're giving me an average price, and out is going to come a year. Okay, so P is my average price. P is 0.765. So 0.765 equals 0.19 plus 0.023T. So we're solving for T to find out what year it was. So bring your 0.19 over and make it a negative 0.19. If we do that correctly on the right side, we're left with 0.023T. On the left side over here, we would have what? 46.746, I believe. Now, with my calculator, I'm running out of room here, but you can see we're going to divide both sides by 0.023, okay? So dividing both sides by 0.023 will leave me with T right here. And with my calculator, 0.746 divided by 0.023 gives me 32.4, okay? 32.4. So, and I don't think that's correct. So let me just see here real quick what I might possibly have done wrong. 0.765 minus 0.19 would not be what I had. Actually, not even close, which is quite humorous. 0.575, and I do apologize for that. And so there we go. All right, now let's take 0.575 and divide that by 0.023, and we're going to get 25 exactly. Now, that's not your answer, because what does it say? What year will it be? Well, obviously 25 is not a year, so go back up here and think right here. T equals 0 corresponds to what year? 1970. Got it? So 0 corresponds to 1970. So 10 years later, that would correspond to what? 1980. So 10 years later would correspond to what? 1990. So 25, which is what T equals, would correspond to what year? 1995. Got it? Okay, so 0 corresponds to 1970. Add 25 to that and you get 1995. So there's the year. Pretty cool, okay? Now, it's going to get a little more difficult on this next problem. So let's see how we do. Okay, now they want us to approximate the total sales in lettuce in the United States in 1990. The total sales. Now, really, to be honest with you, nowhere do we have a model that gives us total sales. So we got to do some thinking here. We have one model that gives us the average price per pound of lettuce. Okay, got it? We have another model that gives us the total amount of pounds that was consumed in 1 year. Now, this is going to be really hard to see, but let me try to explain this to you, okay? Listen carefully. If I want to approximate the total sales in lettuce, think about this. If I knew the total amount of pounds that was sold per year, let's just make up a number, just a really fake number that's not right. Let's say I know that let's say I know for sure in some year, 1990, there was 2,000 pounds of lettuce consumed. Now that's way too low, but just pretend, okay? And then I knew the price per pound. That's LB pound. Price per pound was 50 cents. I'm just making that up, okay? Well, if you know the total pounds is 2,000 and you know the price per pound is 50 cents, if you multiply those two together, you'll have the total sales. Let me say that again. If you know the total pounds that were sold, 2,000 or consumed, whatever, 2,000 pounds, and you knew the price per every pound is 50 cents, that means 1 pound is 50 cents. Then you take 2,000 pounds times 50 cents and you'll have the total sales. So it seems like to me I have two goals. I must first find the total pounds that were consumed in what year? 1990 is what it says right here. And then after I know that, I must find the price per pound in what year? 1990. So once I know the total pounds and I know the price per pound, multiply those together and I've got my total sales. So it sounds like an idea, sounds like a plan. Let's see what happens, okay? All right, here's my model right here for total poundage, okay? And notice your L is in billions, okay? Billions of pounds. So this model here, if I put in a year, I get out the pounds. We're dealing with 1990. Don't forget, 1970 is 0. So 1990 would be 20. So I'm going to put 20 in for T. So L equals 4.5 plus 0.05 times 20. Now 20 represents 1990, and this model here is made so that when I put in a year, I get out the total pounds consumed for that year. So let me grab my calculator real quick. I'm going to multiply 0.05 times 20 and then add that plus 4.5 equals, and I'm getting this, L equals 5.5 billion. Remember, it says right here, L is in billions of pounds. So 5.5 billion pounds my total pounds. Good deal. Now let's find my price per pound, okay? My price per pound. So here we go. In order to find my price per pound, I'm going to erase this. In order to find my price per pound, I want this model here. Remember, this model is the average price for a pound of lettuce. So this is my model I want to use. So my average price equals 0.19 plus 0.023. Remember, this model's made up so I can put in a year and get out the price per pound. And that's what I'm going to do. The year's 1990. So instead of a T right here, I'm going to put 20. And by putting 20 in for T, I should get out the price per pound. So the price per pound equals, here we go, I'm going to type in my calculator, 0.023 times 20 and then plus 0.19, and I'm going to get 0.65. So there we go. So I have up here my total pounds was 5.5 billion. Okay, that's how many pounds of lettuce I sold or consumed. And here's the price per pound, 65 cents. That's my price per pound. Okay, so now think about it. I know how many pounds were consumed. I know how much each pound cost. Multiply those together, and I should have my total sales. Now, the only word of advice I would give you, students, let me get a drink here real quick, is to watch the billions here, okay? I mean, you can write 5.5 billion if you want. A billion has how many zeros? 9 zeros. So you can move the decimal 9 places. Don't just put 9 zeros. If it was 5 billion, then you'd put 9 zeros. It's 5.5, okay? So you move the decimal 9 places, and you'll have a really big number that looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's 5.5 billion. So you can do that and then multiply it by what? 0.65, and your calculator will do that for you, and that's totally fine. But there's an easier way, much faster way, and I'd like to suggest that you do this. Just use 5.5, but remember, when you're all done multiplying, it's in billions, okay? So with your calculator, take 5.5 times 65 cents, okay? And when you do that, you're going to get this, 3.575. Now that's a good answer as long as you remember to put billion after it. So 3.575 billion dollars. So that is the total sales in lettuce in 1990. Really good thinking problem. Really good thinking problem, okay? They rounded, there's the 2 decimal places, 3.58, okay? Alright guys, moving on. Numbers 51 and 52. We are solving the multivariable equation for the letter that's given to us, okay? Number 51 says to solve for y. So we're solving for y. Step 1, simplify both sides. Can't do it. These are unlike terms. Step 2, eliminate fractions. There are none. Step 3, look for the terms that have a y in it because you're solving for y. I only see one. So you want to get this term here all by itself and everything else on the other side. So bring your 7x over and make it negative 7x. Please don't bring a 7 over and make it negative. Then bring your x over and make it negative. This is one term. They're multiplying. You have to move whole terms. So we're left with 3y equals 9 negative 7x. Now divide each term by 3. Like this. These 3's cancel. Y equals positive 9 over positive 3 is a positive 3. A negative 7 over a positive 3 is a negative 7/3 x. Or if you want to put the x up top and call it 7x over 3, that's fine also. Okay, I would accept either one of those two answers. And there's the answer. They put their negative 7/3 x first and their positive 3 second. I would accept either answer. Okay, moving on to 52. Same thing, we're solving for y, okay? So, Step 1, simplify both sides. We cannot simplify here. This is an xy term, this is a y term, they're unlike terms. Step 2, eliminate fractions. I don't see any. Step 3, we're solving for y, so get all of the terms that have a y on one side and everything else on the other side. Well, this term has a y, this term has a y, they're on the same side, everything else is on the other side, we're good. Now lastly, sometimes you have to factor, and in this case we're going to have to factor because we have a y in both terms. So you pull out a y, and if you pull out a y from this term, the y is gone, you're left with negative 3x. If you pull a y out of this term, you're left with 4. There we go. So I pulled a y out of both terms. Now why would I do that? Because the y is being multiplied times this. So to get y by itself, I can now divide both sides by negative 3x plus 4. Negative 3x, positive 4. So these cancel, leaving you with y. And y equals 10 over negative 3x, positive 4. That's a good problem, very good problem, and good problem to when dealing with solving multivariable equations. Doing a little factoring there is a good thinking problem. And there we go. All right, moving on to number 55. If you are paid $12 an hour for up to 40 hours a week, in time and a half for overtime, how many hours would you have to work in a week to earn $6.24? Now, we've done problems like this before. We can try to set up some really long, complex formula or equation if you want to. That's not what I'm going to do. I'm simply going to say this. I know for sure I get 12 bucks an hour, and I know for sure I'm going to work 40 hours a week. So 12 times 40 is 480 hours. Is that, $480, is that how much money I made? No. I want to make this much. So here's what you do. You know for sure you're going to work 40 hours and make this much money. So subtract it out, okay? 624 minus 480. And then you're left with $144 you still have to make. So now you've got to make this money right here using your what pay? Your overtime pay. So you're going to have to work over 40 hours. Let's stop and review again. I know for sure I'm going to work 40 hours. I know I get paid 12 bucks an hour, so 12 times 40 is 480. Now, I know they're not taking into consideration taxes. I get that, but that's just how it is, so it makes the problem a little easier. So 480 bucks is how much I make, but I want to make 624. So subtract this out. I've still got to make this much money. Now, your normal pay is 12 bucks an hour, but you get time and a half. That means they take your pay here, cut it in half, which is 6, and add it back into that, which is 18 bucks an hour. That's called time and a half. If some places give you double time for overtime, if you were given double time, that means you take 12 times 2. You get 24 bucks an hour for anything worked over 40 hours. So time and a half means you take your hourly wage divided by 2, cut it in half, and you get 6, then add that back in. 12 plus 6 is 18 bucks. So for your overtime pay, you're making a lot more. You're making 18 bucks per hour. Okay, now, how much money do you want to make? $144, correct? So if you're making, you know that every hour is $18. Let's divide our hours up into 18 hours, and let's see how many hours I have to work. Okay, I think it's going to be 6. Let's see, 8, excuse me. 8 times 8 is 64. Carry your 6, 144. Yep. So if you work 8 hours, you get 18 bucks an hour. 8 times 18 is 144. So that will give you what you need. So how many total hours did you work? Well, you worked 40 plus 8 more. So you worked 48 hours. Okay, not too bad. All right, moving on to numbers 60 through 62. Okay, in 1911, we have, I'm not sure how to pronounce this, Roald Amundsen, he's going to travel 900 miles at a rate of, it's going to start on October 19th. So I'm going to put 1019, and he's going to average 15.8 miles per day. Okay, miles per day. All right, the other guy, his name's Scott. We'll put an S. He's also going to travel 900 miles. He leaves on November 1st, so 11/1. He's going to average not near as much, 11.6 miles per day. All right, there we go. Now, on which day did Amundsen's team reach the South Pole? All right, well, we're going to need this information here for the next problem, so let me copy that real quick and then get rid of it. All right, well, let's see. Let's see how long it took Roald to make it to the South Pole. Okay, we know he's traveling 900 miles. Okay, and every day is 15.8. So I'm going to take my 900 miles and divide it up into 15.8 groups, and a group of 15.8. Let's see how many days it took him. 900 divided by 15.8 is 56.96. So basically 57 days. So it took him 57 days. Okay, now let's think this through, guys. We're in October, so October has 31 days. So let's see. That's 12 days. So he started on October 19th, and on October 31st, that's 12 days. Okay, we have to get to 57 days. Okay, then all of November is 30 days. Okay, so all of November was 30 more days. So from here to here was 12 days. Add 30 more days, that's 42 days. And now we have 15 days left, right? He's at 42 days. He made it in 57. So 15 days later, that would be December 15th. I hope that's right. December 14th. Yeah, I guess it all depends on if you round up or down on 56.9. And I actually see their point. I'm wrong, because 56.9 really means you have not quite hit the 57 day. It'd be like 56 days and 20 some hours. So I was wrong. We really should use 56. But either way, this is close enough. December 15th, December 14th. But he started, let's go over this again. He started on October 19th. 12 days later was October 31st. And then 30 days later, November was gone. That's 42 days. Then 15 days later, he made it. Of course, if you use 56, like I should have used 56. Then it would be December 14th. Okay. Now, for the other guy, the next question is, on which day did Scott's team reach the South Pole? Okay, let's not make the same mistake I made the last time. We'll be a little more careful when we round here. So he's traveling 900 miles, and he's doing 11.6 each day. So let me grab my handy dandy calculator. 900 divided by 11.6, and I get 77.5. We're not going to round down. 77.5 would be 77 days and about 12 hours. So he made it in 77 days. All right. So let's see what date that would be. He left on November 1st. So he left on November 1st. So now be careful here, guys. At the end of November, when November was all done, he did not travel 30 days. He traveled 29 days. From the 1st to the 30th is 29 days. So far, he traveled 29 days. Now for the month of December, that has 31 days. Okay? So in December, when December was over, he had traveled 31 more days. That's 60. Now he has 17 days left from 60 to get to 77. So November's over, December's over. He has 17 days left. So January 17th is when he would have arrived. Okay? 1912, of course, yes. A different year, 1912. Okay? Alright. And last but not least, because it is covered with a thick ice cap, Antarctica has the greatest average elevation of any of Earth's 7 continents. The thickness in feet of the ice cap varies between 0 and 15,000. That's crazy. Wow. 15,700 feet. That's like 3 miles. Write a compound inequality for the thickness of the ice cap. Then write the compound inequality as an absolute value. Okay. Well, that really is pretty simple, guys. I gotta be honest. I in feet. So we're gonna put I in the middle. I has to be less than or equal to 15,700 and greater than or equal to 0. Now, I gotta be honest, I don't want these equal signs here. The book and I have really disagreed on this. Whenever it says between, that means you don't include those numbers. That's my opinion. Now, if they have, in their final answer equal signs, which they probably will. Oh, they don't. Okay, good. I was gonna say I would disagree with them. Okay, so the ice ranges between 0 and this number here, the thickness. Now, we know how to write this as an absolute value. Okay, we've done quite a few of these. First of all, you find the average of these two numbers here. This number here and this number here. Find the average of those two numbers. So with my calculator, I'm going to add those two together and then divide by 2. That's how I've taught you guys to do this. Okay, you get 7,850. So you're going to subtract that from each part. So 0 minus 7,850. I minus 7,850. 15,700 minus 7,850. Okay, now 0 minus 7,850 is negative 7,850. I minus 7,850. And then 15,700 minus 7,850 is 7,850. Now here's what I've taught you guys. If these two arrows are pointing to the left, and if this number here is the exact opposite of this number here, which it is, then you can write an absolute value inequality. By the way, this number here does not have to match these outside numbers. That is a coincidence. This number right here could be 52, and you're still okay. Alright? Alright, now listen, let me go over the two qualifications again. Alright? Your arrows must be pointing to the left. Okay? These two numbers here must be complete opposites of each other. If that's the case, you can then write an absolute value inequality by taking this part right here and simply inserting absolute value symbol. So, absolute value of I minus 7,850 is less than 7,850. And there we go. So they asked us to do two things. Write a compound inequality. There it is. There's my compound inequality. Right here, write a compound inequality, and then write an absolute value inequality. There it is. Let's see how we did. Hopefully okay. Yep, there's my compound inequality. There's my absolute value inequality. Okay, so not too bad. Guys, I hope this review sheet help video has been a help to you. If you have any questions, never hesitate to call or email. Please study well for your test and make sure you're ready for your test.